Welcome to Programming in Modern C++. We are in week 1 and module 2. So, in the last module we have understood the basic importance of C++ programming, particularly the modern aspects, and we learnt about the course overall. In this module we would like to start by highlighting the differences between C and C++ programs to make you understand the ease of programming in C++. Right. So, when we discuss that, please please keep in mind that this is not related to compatibility of these two languages. That will be covered in a separate tutorial. Here what we are going to do is we will take programs in C and write their appropriate C++ equivalent and try to show you how it becomes easier to write more efficient, safer, less error prone code in C++. So, there are several 6 different examples, very common programs which I am sure in C you must have written all of them, or at least most of them. So, I will use them to provide a comparison with the corresponding C++ program. So, the entire story as the world starts with the hello world, which is the basic handling of the I/O. So, this is the hello world program which all of you know. So, you have to include stdio.h in C, you know that, and you do a printf with a new line, right. That is a hello world in C. In C++, instead you use a different header called IO stream, and note that in IO stream there is no h.h. We will talk about this more. And you use the same string or a similar string to do the hello world, but you use an output streaming operator, this is called, and stream to std out, std : cout, which is actually the standard output, and then you put a n line marker which gives you exactly similar output as in here, right. Okay. So, having said that, now if you compare, what you see is IO header is different, right. You are using printf to print to console, which is std out, and here you are using an operator less than called output streaming to stream to the console. The terms are also kind of changing. It is not only about syntax, but in typically C you say that I print, in C++ you say I stream. The console is the std out file. Here it is std : cout O stream. O stands for output, and that is in the standard namespace. We will talk about it, what it means. Printf is a variadic function in the sense that it takes any number of arguments after a format string. The format string is important, is mandatory at the beginning, and then you can have any number of them as you know. But this operator is just binary. It just takes it takes the stream and what you want to print, and does the printing, does the streaming, and then returns the same stream, right. We will learn more. \n is used for going to new line. Here it is std : endl in the std namespace, end line in the namespace, where \n is an escape new character, std : endl is a stream manipulator. So, we will see that besides putting a new line, it can actually do more stuff, and it is a functor. We will talk about this. I am just trying to show you the parallel between these two. Okay. So, let us go to the next example, which is adding two numbers and handling the IO again. Okay. So, we want to add two numbers, read them from the input, add two numbers and write their sum. A simple program which you must have written n number of times in terms of C. So, let us see what are the things that are same, what are the things that are different. Naturally, the input output library is different, we have already observed that. Now, here you declare A B, here also you declare A B, these are what you want to read. So, you put a message to the user asking to input the numbers, here you do the same, but it differs in scanf as it differed in printf. In scanf, you present it is a variadic function again. So, you present a format and then you put all the different inputs that you want, right, input variables. And the key thing is, while you put this, you do not put it as the name of the variable, you put it as the address of the variable, right, you put an ampersand, you know that is required to be able to read from the input. Whereas, in C++, you use the input streaming operator, which is coming in from the std::cin, which is the standard input console, into the variable, and the variable is not written as with the address, it is just written without anything, it is just written as a simple variable, right. So, syntactically it makes it much easier to deal with it. Then you make the sum of them, you do the sum of them here as well. The only difference I show that the sum variable needed to be declared before, and this is what you read in Kernighan-Rich's book, that all variables must be declared before the first executable statement of the function, right. So, it was declared before, but here what I have done is I have declared it in the middle. This is what C++ allows from the very beginning. In fact, C also allows it from C89, right. So, but I have shown it a comparison. So, this basically you can note that this basically is written for KNRC, where it was not allowed to put the variable declaration in the middle of a function, but I just wanted to show you that. Now, this is also used allowed in C, but C++ will often have that. Rest of it is printf and the std::cout, which we have already seen in the earlier example. So, if I go back to the comparison proper, then these are the things that you must note, that you are using scanf in C to read from the console, you are using input streaming operator to read from the input stream, the console in the C++. Console is std in, here the console is std::cin, which is a I stream, I stands for input, is the std namespace. Scanf is a variadic function like printf, whereas operator input streaming is a binary operator. This comparison is similar to the print. This is very critical. In C, you need to take addresses of variables that you want to read. In C++, you do not need to do that, you directly use the variables. This difference I have already mentioned, all variables need to be declared first, this is a KNRC, whereas sum can be declared whenever it was actually needed, and the same thing is allowed in from C89 as well. Then you need formatting %d for variables, whereas no specific formatting is required. In terms of for example, here you are using formatting of %d to say that you read A, you read B, or you scan A, you scan B as an integer. Similarly, here in printf you are doing this, you say that you print A as an integer. Here you do not need to say any of that, you just write this. So, that makes life lot more simple. So, it is kind of the kind of way you want the input or the output, you just keep on writing that with the repeated streaming operators, and this will serve your purpose. What happens in C++ is since you have already declared a and b as int or sum as int, while you try to stream it to the output or while you are trying to stream it from the input, the compiler knows that it is an integer. So, it knows what is the corresponding formatting that needs to be specified. This is possible because you have these operators, and it was not possible because these were functions which were variadic, which had no way of knowing what your parameters and what the types of those parameters are, because it is variadic. There is no signature which says this is the type of the parameters it is getting. So, it knows that it will get a constant string at the beginning, which is a format. After that, it can put as many variables as possible of any type whatsoever. So, printf scanf cannot have this smartness of knowing or deciding the format based on the type of the variable, which C++ streaming operators make heavy use of, which makes programming far more easier in this language. So, let us move to the next example, which is finding the square root, right, which is again a very simple, these are all very simple programs. So, besides the input output, for finding square root you need to include math.h, right, the mathematical library in the C standard library. Equivalently, in C++ you include CMath. So, we will discuss this more, but this is just to show you that anything that you have in C standard library, you can use that library function in C++ by including the library as C followed by the library name. C meaning that this is a C library, and not having the .h. So, math.h becomes CMath, stdio.h becomes cstdio, and so on. Okay. Then what you are doing in C++ is you are saying that anything that I do with the library will be in the standard namespace. We will talk about what namespace is, but just think of now that it is a way to define the symbols with std::. So, earlier we were writing std::cout, saying that std, the cout symbol, which is the output stream O stream, is defined in the std namespace. Now, we have said that we are using std namespace. So, I am just writing cout. So, by default the compiler looks in the std namespace and checks is there a cout. It finds one and uses that. So, this actually means this, right? But it eases a lot of typing of the code. For example, I am just writing NPTEL, but it actually means std::NPTEL. I am just writing cin, it actually means std::cin, right. So, that is the advantage of having the using part of it. Okay. So, then what we have the print, we have the print message, cout, this we have seen, scan to read the input, and then you do square root for this. Again, here I have defined it in the KNR style. I can define it, declare sqrt underscore x right here as well. So, sqrt underscore x has the value of the square root of x, right. Then I print x, I print sqrt x, similarly I do in. So, it is rest of it is all very similar, and since it is a double, I am using a formatting which is for double. Here again, as I said, that for this or for this I do not need to use any formatting, because it knows, the compiler knows from the type itself, right. So, here are the main differences. Here math library is math.h, here it is. C math, C standard library in C++, percentage %lf for formatting, here it is not required. Square root is a C standard library function which C++ can use. So, you can whole of the C standard library can be used in this way. Of course, you see that there is a difference in the precision of printing. Here you can see that in C you are printing up to 6 decimal points, that is precision is 6, where here you are printing 5. This is for the default setting of the compiler that is doing C as well as that is doing C++. Later on we will show how to control this. You can decide as to, in C you know how to do that, the size dot precision kind of qualifier with the format string. In C++ also we will show how to control the precision as to what you want, but I just wanted to highlight that by default in GCC C follows %lf follows one precision and C out for double follows a different precision, right. So, this is just a gives you an idea of how to use the C standard library in C++ as well. Now, having said that, so let us take a quick look as to how does a C standard library work in C++, right, and what is the role that the std namespace play there. So, what I have is a C standard library where all names are global, as you know, in C everything, all functions are global. So, it has global, a whole collection of global functions and some global symbols like std out, std in, these are of course global functions. Now, C standard library, all names are within std namespace, standard namespace. So, your C out is std : you have seen this, and the way to do this is using, so that you do not have to. So, this is a comparison of code where you are using the namespace std. So, you write less, here you are not using, so you write more. It is a syntactic difference, nothing else. Okay. So, this is the basic of the libraries. Now, how to include the headers, right? That is the most important thing. So, there are kind of three possibilities, that you are writing a C program or you are writing a C++ program is the first choice. You want to use a C header, C library, standard library header, or C++ standard library header, right. So, how do you write the header in every case? Now, writing a C program using C standard library header is known to you. You do an include of the library.h, stdio.h, stdlib.h, math.h, and so on and so forth. You have been using it, so you are already familiar. This is not possible, that you are writing a C program and using a C++ header, that is not possible. So, that is ruled out. Now, in C++, if you want to use a header, then you use no.h. You will just write IOStream, you will just write vector, you will just write stack, you will just write algorithm. So, these are the different components of the C++ standard library, and you do the same hash include, but no h.h. If you are using a C standard library component, then the change that you have to make is put a C before the library name and not use a h again, .h again, and the names will be in std namespace. So, it becomes C stdio, right. We have seen this. So, when you have C standard library header used in C++, so we wrote C math, and in C it was math.h, and it is in C++, it is actually std : sqrt, not just sqrt. Why? Because CMath is a C++ library now, and it is in the namespace, is put in the namespace of std. So, every symbol in math.h, which has become now CMath, are available not in the global namespace, but in the namespace of std only. So, you have to use it with that. Now, if you happen to use a C standard library component in C++, not with the C++ style, but just as math.h, you are perfectly okay to do that. It is not preferred, but it is not wrong. So, you can do that, but if you do that, then the name is still, the name from math.h is still in the global namespace. So, you will not use std : sqrt, you will just use it as sqrt. Right? But what I will strongly suggest is do not do this. Right? Finally, what if you include a C header as with a .h, iostream.h. Now, this is something which is disastrous, because the good part would be that in many of systems this will give you an error saying that iostream.h does not exist, then you got saved. But in some old systems, particularly, a iostream.h file may also exist, and if it does, then it is some old wrong stuff. This C++ standard library with .h extension used to be there much earlier. These are now deprecated and completely out of use. So, it may be very dangerous if you happen to use them, and if your system or your compiler is old enough so that it still has some copies of iostream.h or say vector.h and so on. Right? So, always remember that if you are using, when you are using C++ standard library, never use .h. Right? Okay. So, I move on to the last example, or no, sorry, there are one more. So, the next example, which is doing the addition of n numbers, which is something very, very common that you have done often. I have the input libraries, namespace, declarations here. I read the number of numbers, and then I say that I will basically do an addition of integers from 0 up to that number. Right? So, that is what I am doing here. That is what I am doing here, and then I will print, which is, this is a very straightforward simple program. The feature that I want to highlight is, if you are writing it in C, you can write, you will have to declare int I here, or if you are doing KNR, or you can declare it somewhere here, int I, if you are using C89 or later. But in C++, you have to use, you may use, not have to, you can use it as well here, but you may use it right inside the loop. If you use it right inside the loop, it is just a local declaration here, which is often very useful, because wherever you need locally, you can just within that control construct, you can declare and use it, and outside of that it is not defined. So, it can be reused, that same name can be reused. You may note that from C99 onwards, this has also been included, this feature has also been included in the C language. So, if you if you are on KNRC, which is very unlikely, you will have to write it here. If you are on C89, not on C99 onwards, then you have to use it here. If you are C99 onwards, then you can use it in any one of the places, right. So, this is some of the basic nuances that you have. Now, let me move to the last example, which is regarding Boolean. Now, Boolean, as we all know, is an important feature of the language. We always need to make choices, true or false, and we need a Boolean value. So, in traditional C, say K and R C, what will be Boolean? So, typically you can have Boolean as a manifest constant, true, defined as 1, and another false, defined as 0. You can put, say, x is assigned true, and then if you print, it will print it as 1. Right? So, using int and hash define, you can create a bool kind of variable in KNRC, which is the only possible way. So, otherwise, I mean, basically you are maintaining it as an integer only, but you are just interpreting it as a Boolean. If it is 0, you say it is false. If it is not 0, you say it is true. Now, when we move to C89, things improved. So, C89 provided a new header known as stdbool.h. This header is provided specifically to support Boolean value as bool. You want to call it bool as if it is a different type. So, it includes bool, and it actually is the defined type is underscore bool, but there is a macro which defines bool to underscore bool. There are macros which define true as 1, false as 0. Mind you, these are predefined in stdbool.h, and these are all in lower case. So, with that you can write this. Mind you, this is defined in that stdbool.h header. So, if it is not included, this code may give an error, but some other C standard library components also in turn include stdbool.h. So, it is possible that if you are including stdlib.h, you may not need to include this, but I have specifically shown it here, so that you can have these macros available, and there is also a macro to check that whether you have done it, which give you a sense of a true Boolean type. In C++, it goes further. It is not macros which are defining it. It has been supported as a built-in type, like you have integer, like you have double, you have a bool type, and like 1, 0, 2, 3, 4, 17, all of these are literals of int type. Bool type has two literals, true and false. So, they are not mappings to 1 or 0, they are just literals by themselves, and C++ does that. So, code wise it looks same, and certainly you do not need to include anything special, because it is no more a feature of the library, it is a feature of the language. So, in the leftmost in KRC, there was no support in the language nor in the library. So, you are creating and interpreting your bool in your own way. In the second column, you are in C99 onwards, C89 onwards, where you have a library support to give you a feeling of a Boolean bool. And rightmost column in C++, you now have bool as a built-in type with true and false being actual literal. So, it is now a language support, no more a library support, right. So, that is kind of the development that has happened, and that gives us a very easy way of using bool in C++. So, to summarize, I have tried to highlight a few differences between C and C++, which are of fundamental nature, particularly in terms of I/O, input and output, variable declaration, and the use of standard library, which are the commonest things you start doing in starting to program. And we have seen that C++ gives us better flexibility in terms of declarations and input output, and makes it simpler to deal with, and many C constructs and functions get simplified in C++, which help to increase the readability as well as the ease of programming. So, with these words, I will conclude on this module 2, and I hope these examples and variants of them you will not only study in the module, but you will start practicing them on the system that you have installed, the GCC, both in C as well as in C++ versions, and actually check for yourself what you are getting, and then you make modifications to understand that how elementary C++ programs can be created corresponding to the C versions. Thank you all very much. See you again next module.